Hi, I'm going to make the second installment in this video series on the polynomial check for understanding that we had in April. And I'm going to focus, this is designed again for folks who had trouble in a particular section. I'm going to focus on the expanding one. That's 2a, 2b, and 2c. So if you had trouble with these, please check this video out. So expand is another way of saying multiply the factors out and get it into, of course, its standard form. And so the first thing we're going to do is deal with 2a. Now 2a is just a standard FOIL situation. I've got a binomial 2x plus 5 times another binomial 3x minus 4. You might notice that's a linear equation times another linear equation. I have two linear equations. I should get a square or quadratic second degree equation. So I'm going to first deal with my first part. So I'm going to FOIL this. Okay, so we're going to FOIL first. F stands for first. So my first is going to be 2x times 3x. 2x, right? Type that again. 2x, 3x. Okay. My outside is going to be 2x times negative 4. My inside, that's the I part, is going to be 5 times 3x. And my last is 5 times negative 4. Okay, now let's simplify each part of this. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. 5 times 3x is 15x. And 5 times negative 4 is negative 20. All right, so let's look at this here. We've got a second degree part. So I'll write that in here. 6x squared. And I've got minus 8x plus 15x minus 20. Now I need to combine my like terms. My like terms are my outside and my inside products. So I'll rewrite 6x squared. Negative 8x plus 15x is going to end up being plus 7x. And then I've got minus 20. And I'm done. If you're having any trouble with this, I highly recommend using the FOIL approach. If this was a trinomial or a 4 or 5 degree term, then you might find it useful to organize it using a table, which I can come back to and try on a different video. If you would like, let me know in comments or send me an email. But using the FOIL approach will systematically make sure you take care of the first parts, the outside parts, the inside parts, and the last parts. And then you'll have taken care of everything. You will have doing the first part first, gets the highest degree piece first. Doing the outside and inside puts the middle degree, and doing last has the lowest degree come in last. As you can see, we ended up with 6x squared. We have our middle degree, our linear terms, and we have our constant term here. So our next one, okay, I'm going to go to the next one. The next one, you might notice these are very similar. So 3x plus 8 and 3x minus 8. If you do not recognize this to be a special case, then you can do a FOIL, of course. So I'll do a FOIL first, because that will certainly work. Okay, so first, outside, inside, and last. Okay, my first ends up being 3x times 3x, which equals 9x squared. My outside is 3x times negative 8, so that's negative, so 3x times negative 8, which is going to be negative 24x. My inside is going to be 8 times 3x. Notice that I've got basically opposite products that are going to happen here. That's going to be 24x. You can see right away these two are going to go away. Negative 24x and 24x are going to cancel each other out. This is going to have no middle term. Finally, I've got 8 times negative 8, which is going to be negative 64. So when I put all of that together, I've got 9x squared minus 24x plus 24x minus 64. And that middle stuff is going to go away. I'm going to do a strike through on that so you can make the point. Boom, it's gone. And I'm left with 9x squared minus 64. All right, this is a difference of squares special case. 9x squared is a perfect square of 3x. 3x times 3x. Negative 6, so 64 is a perfect square of 8. If you see a binomial sum times its sort of Tweedledee twin, that's a binomial difference. First terms are the same, last terms are just opposites of each other, then you have a difference of squares special case. And you can shortcut this. You do not have to go through all this FOIL if you remember the basic structure of a plus b times a minus b is going to equal a squared minus b squared. So all I have to do is square the first ones. So that's 3x squared, or 9x, 3x times 3x, so 9x squared. And then I square the last ones, and that's going to be a difference. So 8 times 8 is 64. So there you have it. It's just a difference of squares. It's a difference of squares here. So that's a special case. If you're having trouble with the special cases, please, please, please review that. Next one is also a special case. It's a perfect square. Now you could FOIL it first. So we'll FOIL it first, outside, inside, and last. And you might be thinking, well, where are my inside and outside? Well, if it's squared, that's just 5x minus 9. Oops. 5x minus 9 times 5x minus 9. I'm squaring the same dang thing. So my first is 5x times 5x, which is going to be 25x squared. My outside is going to be 5x times negative 9, which is going to be negative 45x. My inside is going to be negative 9 times 5x, which is just the same thing, negative 45x. So I'm just going to end up taking my inside or my outside and doubling it because I'm adding two of the same thing together. That put together is going to be negative 90x. Then I'm going to have negative 9 times negative 9. The negatives will cancel out. That's negative 9 squared, so that's going to be positive 81. Okay, so I'm going to put that all together, and I will have 25x squared minus 45x minus 45x plus 81. And the negative 45x and the negative 45x combine, and that will be 25x squared minus 90x plus 81. But this is a special case. So the special case being a perfect square. If I have a plus b squared, I end up with a squared plus, if you have a plus, sorry, I was interrupted, but I'm back. If I have a plus b squared, the a, that's a plus b times a plus b, right? So let's write that again. That's a plus b times a plus b. So my first is going to be a squared. My last is going to be b squared. Oops. It's going to be b squared. Okay, so plus b squared at the end. Okay, no matter whether that's minus. Then my middle is going to be a combination of a times b and b times a, which is the same as a times b. So I've got a plus ab, which put together becomes a 2ab. That's where that comes from. Now, what if this was a minus b squared? Well, that's the same as a minus b times a minus b. In this case, my first is still going to be a squared, it's a times a. My last is going to be negative b times negative b, which will still be positive b squared. And then my middle is going to be minus ab minus ba, and ba is the same as ab. So minus ab, which is minus 2ab. Okay, so that, if you can remember that structure, that's going to help you out a lot with these sorts of problems and with a lot of other similar ones. So if you remember, so in this situation, we're really dealing with an a minus b thing. So a is, in this case, the stand-in for a is 5x. So we'll have a 5x will have to be squared. Our last part is negative 9 squared. So at the end, we've got negative 9 squared. That negative is inside the parentheses, so we will be canceling it out. And then in the middle, we're going to have negative, we'll have 5x times negative 9 and negative 9 times 5x. Well, that's just the same as 5x times negative 9. So really, I have a couple of these. I'm going to rearrange that so you can see it. Okay, so I've got those. And once I've sorted all of that out, this 5x squared is 5 times 5 times x times x. So that's going to be 25x squared. This is going to be a negative 45x. This is also going to be a negative 45x. So those are going to come together. This negative 9 squared is 81. So this comes together as negative 90x. So I'll get rid of that addition. So this is my a squared, 25x squared, my a squared, since my a is 5x. My b squared at the end is negative 9 squared, which becomes 81. And my middle term is 2ab. So it's 2 times 5x times negative 9. 2 times 5x is 10x, times negative 9 makes 90x. And so if you can remember that structure, your life will be a lot easier with these sorts of problems. Our answer is 25x squared minus 90x plus 81. I want to make a really strong pitch for practicing the perfect squares if you're having trouble with them. The perfect square special cases and the difference of square special cases. The perfect squares are going to play a big role in your success on completion of the square, in your success when you get to geometry and you're working on things like circle equations, ellipse equations, and hyperbola equations, because they're going to allow you to organize, and then also a different kind of parabola equation, which is in the realm of conic sections. All this stuff will come back and make a big difference. Your difference of squares play a big role in being able to rationalize denominators if you have a radical in the denominator, and are useful in a whole bunch of other situations. So these are like math facts, foundational tools. A plus b times a minus b equals a squared minus b squared. A plus b squared, the sum of a and b squared, is going to be a squared plus 2ab plus b squared, and the difference of a and b squared is going to be a minus b times a minus b, or a squared minus 2ab plus b squared. Please familiarize yourself with those and practice them if you're having trouble. I hope this has helped.